Hello everyone, my name is Cal Demis. I am doing this video for North Seattle College for my Physics 221 class. The title of my experiment is Projectile Motion. Before doing the experiment, I wrote down some questions that I wanted to answer. Sorry, I do have a bit of a cold, so I might cough or sneeze. So sorry in advance. And here it goes. So the purpose of the lab is exploring the idea of a projectile motion. And the two lab questions I wanted answered was, what kind of path do the projectile motion follow? What is the effect on acceleration and velocity? The materials I used are a golf ball, a camera, a table, and a Logger Pro software. So let me show you my experiment video before we go on further. Okay, so this is my video. So as you can see, I am rolling down a ball on a table right here, and it follows this path right here and falls down on the ground right about here. Just to see it one more time. Okay. So before we go into the details, I just wanted to mention Galileo Galilei was the first person to accurately describe the trajectory of a projectile motion, and he carried out a very similar experiment in which an inked bronze ball was rolled down an inclined plane, then across a horizontal table and off the edge. Where the ball landed on the floor, it left a mark, allowing the horizontal distance traveled by the ball after it rolled off the table to be measured. So in my case, would be right here where the ball lands, and from here to here would be my distance. And on my video right here, you can see a ruler which I used as a scale to analyze my video. So Galileo varied the horizontal velocity of the ball and the vertical height of the table. And these experiments led him to the understanding that projectiles follow a parabolic trajectory, right here as we can see on my experiment as well. And there are two components in this motion, which I do have a better picture right here, which I have gotten from Google, and the copyright is right here on the little writing here for anyone looking for the picture. So I found it on Google, and there are two components: the constant vertical acceleration and the constant horizontal velocity together to make the parabolic trajectory right here. So the only force acting on a projectile after the launch is going to be the force due to gravity, which is directly downwards to the center of the earth. And projectiles have a constant vertical acceleration and a constant horizontal velocity. And based on the experiment we did, we can easily see the motion of a projectile has two components. Let me pull up a side by side if we could see it right over here. So I'm trying to align the tables. So this is my table right here, and I would have my constant horizontal velocity here. I would have my constant velocity, horizontal velocity here, and the ball dropped vertically. So this would be the that would be the constant vertical acceleration due to gravity, and the trajectory of the motion would be right here shown in the blue dot on the video and the red dots on the picture here. Okay, so let me try to tidy this up. And Galileo, by making precise measurements, he was able to determine that the vertical displacement of a falling body was related to the square of the time, which we use in our calculations as S equals to 1/2 gt squared. And so the green ones show the horizontal velocity, the blue ball shows a constant vertical acceleration, the red ball shows the trajectory. So now let's go to our analysis of my video. So once you insert the video on the Logger Pro app software, you should be able to get some graphs and tables right here. So I do have my graph right here. So the first table shows my time, x, the distance on the x distance, on the y direction, and my velocity both in the x axis and the y axis, and also my acceleration due to gravity over here. So right here, I do have the graph for acceleration, and you can see just like the x direction distance, the y direction. Let me see if I could show you each individually, then I can pull up everything in one graph. So that should be your x velocity, y velocity, just the acceleration. Okay, so this one is easier to see because you could see easily how the ball was like going on a constant on the constant velocity, then dropping down. Okay, if I have all of them up here, it would look a bit crowded, but the whole point is you are gonna have a horizontal velocity, which is just xv. So your horizontal velocity is gonna be constant, and you're gonna have an acceleration due to gravity, which should be closer to 9.8. So somewhere around here, let me see, 9.27. So somewhere around here is going to be your gravitational acceleration. So it does not look like this one. Some mistakes I would want to mention might have caused this discrepancy would be like a human error when I was analyzing the video. I did have to like add the points myself, like following the ball and adding the points. My starting coordinate is right here, and yeah, you might have some mistakes on scaling as well, so that may be why the graph is not as perfect as it should be. Those are the errors that I can think of right now, but the whole idea and the whole concept to answer my lab questions was, what was the velocity and the acceleration gonna be? And in summary, I can say the first thing is Galileo was the first person to accurately describe the trajectory of the projectile motion, and the projectiles follow a parabolic path, and the only force acting on the projectile after the launch is the force due to gravity, which is directly down towards the center of the earth. And I would have a constant horizontal velocity and a constant vertical acceleration due to gravity. And I would have a trajectory when I am having a projectile motion. Thank you.